today we are going to learn Prism, right? Prism is a very important topic for JEE mains. Okay, so what is Prism? Prism is a portion of a transparent medium confined using two plane surfaces inclined to each other. ये बोलছে two plane surfaces. ये देखो PQR and EDF. These are two plane surfaces inclined to each other, right? So this constitutes a prism. QPEDRQ. This whole is one prism. This whole drawing is one prism. I have drawn the surfaces, different surfaces. I have drawn the first surface and the last surface and one surface in the middle of the prism. So this total QPEFDRQ, this constitutes a prism. And what are the refracting faces? The refracting faces are this one, PQFE and EDRP. These two are the refracting faces. Let me draw it. This, 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 this. This one is the refracting face, and this one. These, this. Understood? So these are the refracting faces of the prism. Means light will come and incident on this face like this, on this face like this, like that, and it will get refracted, and it will get refracted to this face. Like this. Understood? So this is how the prism works. Now, refracting angle or angle of prism. The angle included between the two refracting faces is called the refracting angle. This angle is called the refracting angle. The angle between two refracting faces is called the refracting angle. This angle or this angle or this angle. This angle is known as the refracting angle or angle of prism. Now, principal section, very important point, principal section. The triangular cross section cut by a perpendicular plane at right angles to the edge of a prism. What did I say? The triangular cross section, see this one, the triangular ABC, the triangular cross section cut by a perpendicular plane. Cut by a perpendicular plane means you take a knife and cut the prism into two halves from this point. From this point, if you cut the prism into two halves, then suppose your two halves becomes PQRCAB and ACDEFB. Then this is the principal section. ABC is the principal section, right? Which means the refracting surfaces are AB and AC. This is the principal section. ABC is one of the principal sections of the prism. Understand? You could have got cut here also like this. You could have cut a principal section like this here also. So this one would have been your principal section. Understood? Everybody is understanding or not? Please reply.
Yes, sir.
Yes, sir.
दीप्तदीप.
हाँ सर बोललाम तो.
Or Gujik?
Sir.
Okay. Now we are going to a very important section. I am clearing this diagram, and now we will learn the refraction of light along the principal section of a prism. So let me take a principal section. ABC of the prism, and a ray of light PQ was incident So now I shall draw the normals. Right? We draw the normals. So we have taken a principal section of a prism ABC. Now this line PQ is incident on the AB surface, AB plane of the prism. This is the refracting surface of the prism, and NO is the normal on AB. So since it is moving, the ray of light is moving from air to glass, so this will be deflected towards the normal, right? So the PQ is refracted as QR, right? PQ is refracted as QR. If this glass prism would have not been present, then this PQ ray should have traveled along PM. This PQ ray should have traveled along QM, right? But as this glass prism was present in the path of the ray of light, finally the ray of light emerges as RS. So this angle, so this angle is known as the angle of deviation, delta. This angle is known as the angle of deviation, delta. We will find out the value of this angle later on. So what happens? PQ was a ray of light traveling from air and it encountered a prism, and due to that it got refracted, and as the prism is made of glass and glass is more denser than, optically denser than air, it moved towards the normal. Again what happened? Then at the refracting face AC of the prism, the ray of light traveling from glass to air, instead of following its natural path, it got it gets refracted and follows RS, and N dash O is the normal on the face AC. So it moved away from the normal. So instead of following this path, it followed this RS path. Understood? So this is how the refraction from a prism works, right? This is how the refraction from a prism works. This is angle of prism. Let it be angle A. This is angle of prism, and delta is the deviation. So due to this prism, the ray of light PQ, instead of going to PM, is following now RS. Understood? So let us find out the value of this angle delta. Let us find out the value of this angle delta in terms of the angle that we know. Now what we know, this is angle I1, right? This is angle R1. This is angle I2, and this is angle R2, right? So these are the angles that we know, and A. Now, what is the value of this angle delta? Now let in triangle C, in triangle TQR, in triangle TQR, in triangle TQR, in triangle TQR, we can write delta is equal to, instead of delta I am using capital D. Okay, so delta is equal to, we have known from class 9 and 10, the sum of external opposite angle is equal to the sum of the angles of the external opposite sides. Means this angle delta is equal to this angle and this angle. Do you agree or not?
Yes, sir.
So angle delta is
Yes, sir.
angle D is equal to angle TQM, sorry, TQR plus TRQ. Correct or not?
Yes, sir.
Angle TQR is plus angle TRQ. So what is angle TQR? What is angle TQR? This angle TQR. See, this I1 is this. So if this is I1, this angle and this angle are same. TQO and this I angle are same, right? If vertically opposite angles.
Yes, sir.
Yes, sir.
And this angle TRO and I2 are same.
Yes, sir.
So we can write, and what is this TQO? What is this TQO? I1, right? So what is this angle TQR? I1 minus R1. TQR will be I1 angle TQO minus TQO minus R1 plus angle TRO minus R2. See if this is correct or not. Angle
Yes, sir.
angle TQR is equal to angle TQO minus R1 and angle TRQ is equal to TRO minus R2, right? So this will be equal to, we can write I1 minus R1 plus I2 minus R2, right? We can write, or we can write I1 plus I2 minus within bracket R1 plus R2, right?
Hmm.
Now, in this quadrilateral, see, in quadrilateral AQOR, in quadrilateral AQOR, in quadrilateral AQOR, what we can write? Angle A plus angle QOR,
Equals 180 degree.
very good, equals 180 degree, equals 180 degree. Now, what is, we can also write in triangle QOR, in triangle QOR, what you can write in triangle QOR? In triangle QOR, you can write,
R1 plus R2 plus angle QOR equal to 180 degree.
very good, R1 plus R2 plus angle QOR is equal to 180, right? So from here, what you can write from these two equations?
Angle A is equal to R1 plus R2.
Very good. Angle A is equal to R1 plus R2, right? Angle A is equal to R1 plus R2. So finally, what you can write for D? So angle of deviation, capital D or delta, is equal to I1 plus I2 minus A. Okay, so
R1 plus R2.
this is the expression for the angle of deviation. This is the expression for angle of deviation. Okay. So our next topic is to find out angle of minimum deviation. Angle of minimum deviation. So angle of minimum deviation is given by del m. Angle of minimum deviation del m, right? For my I will write it as dm. Okay. I cannot write delta in this whiteboard, so I am writing dm for delta m. Okay. The curve, let me draw the curve for this. For angle of minimum deviation, this is the curve for angle of minimum deviation. This is in along this axis is angle of deviation delta. Angle of deviation is along this y-axis, and angle of incidence is along this axis. Angle of incidence I is along this axis, right? So you see that for a particular value of I, for a particular value of I, the value of D is minimum. So this is dm. This is dm. This is at a particular value of I where dm is minimum, right? And this dm is minimum when I1 is equal to I2. When the condition is when I1 angle of incidence is equal to angle of exitance, we can say that dm is maximum. How can you say that? See here at this point, at this point, and at this point, right? At these 2 points, what is the coordinates of this point? The coordinates of this point are I1 and delta, I1 and del, and the coordinates of this point are I2 and del, right? The coordinates of this point are I1 and del, and coordinates of this point are I2 and del. So this straight line joining the two, the length of this straight line is I1 minus I2 or I2 minus I1. Better to say I2 minus I2. So this I2 minus I1, I2 minus I1 will be minimum where? Here this straight line becomes a point at this point, right? So we can say that the length is 0 of I2 minus I1 is 0. So I2 minus I1 is equal to 0. So what we can say that I2 is equal to I1. Understood?
Yes, sir.
Yes, sir.
Okay.